Good morning, everybody. Is it morning? I don't know. It's that weird, funny time between 12 noon and 1 p.m. I don't know. Is it still morning? Who knows? Right. Let's see. So, yes, dog fooding. I was trying to work out how to put emojis in Illustrator, but I haven't worked it out yet. It'd be nice to get a little picture of the dog and the canned food next to each other on the thumbnail, but we'll see. Maybe I'll work it out. So, what are we doing? We're getting this working. This, we're trying it. So yesterday we got to the end of this, and we can record placement set in place now. Yay! And then we started using it, aka dog fooding it, like making sure it works in a real world scenario. And we ran into a bug. Not a bug with my code, I might add, which is nice. Someone else's code. And there was a bug with the Surday serialization. And there's been a couple of replies since then. And I had a look at trying to do some workarounds today. The author was sort of helpful and reminded me that there are other ways that you can do this stuff. But it turns out you can still use Surday to do it without using flatten, but you just do some of the deserialization manually. So what we wanted was the fields from the CSV file the unknown fields from the CSV file into a hash map, but it didn't work when they had when they could be converted to integers. Where we always wanted strings, it just errored out. But it turns out if you do this, where is it? If you if you do it like this, you just have a part mapping record which just has all the fields in it, right? And then in your code you pull out the fields that you want manually. You can sort of work around the problem. So that's what we did, and it works. And I did a regression test for it somewhere around here. Yeah. So we've got a regression test where we create a part mapping record with a name, a value, a manufacturer, and a part number, all of which have got numbers in them, and it works. It's okay. So we've got that. So we know the workaround works. So we can continue with trying to see if it works. Let's go. Let's carry on then. Right. So yesterday we had bundles of fun with CSV files, and I was getting a little bit hangry towards the end of the stream yesterday because, I was hungry and things weren't going well, and it was a bit frustrating. There we go. We'll see where we can get to today. So we started creating a CSV file, this thing, and we can edit it now, and it's good. And this is where we ran into the issue with this file, because it was moaning about this, and I think yesterday it was bitching about 42. But I think the actual, I don't know, I'm looking at the counter down the bottom here underneath my head, which shows you the index. It's like 42. But 42 is like still like this character. I still don't understand where that 42 is coming from. Like, even if you select all this, it's like, what is this 42? I suppose maybe 42 is the start of line. I guess it must be. Okay, fine. So we got the answer to that. So CSV file. Okay, and we're going to try running the same thing we were doing yesterday, but running it now, and it's what it does. So it finally reads the part mapping record, which is what it struggled with yesterday, but now it's saying there's no part. So we need to create a part in the parts file with these values. So let's do that. Let's see if we can cajole this CSV thing into using the right. See, look, this one's decided it's using comma by default. Like yesterday, the other one was like tabs for no reason. Maybe it's because it like cached the fact that it was a tab or something, because when Excel saved it as a CSV file, it put tabs in there, even though it's a CSV file, not PSV file. and then it cached that, and then that's why it got stuck on it. But who knows? Anyway, so manufacturer, and part. No, not part. MPN. Right. That's what we want. Can we use the table editor now? We can. Amazing. So the part mapping file has got. Can we use this now? We can. Molex in it. So the manufacturer needs to be Molex, and then the part number needs to be this. There we go. So now we've got our part defined. Amazing. Right. Okay, now what happens? Well, it doesn't quote things, does it? Kind of want it to quote things. I guess technically it doesn't need to. We're going to see what happens. Because, you know, dog fooding. It worked. Well, we think it worked. Let's have a look. A1. There you go, look. Auto-selected, because it's the only matching thing. A. And then we just have to repeat that process for all of the rest. I mean, yeah. We can. Let's do a few. And then, you know, there's a few parts on this. It's not too bad. Quite a lot of them are the same, so, you know, like all these are the same. So once we do it for one, it'll work for the rest. I think one of the other things we might need to do is the wildcards for the part mappings. I don't remember whether I did them or not, because it was so long ago when we were doing part mappings. Okay, so it's done this one, and it's done this one. So now we're on to this one. So we've got this name and this value. So the process is copy the name into the name field. Yoink. Copy the value into the value field. No, that's not the value, is it? And eventually over time you'll build up this database and it won't be so quite laborious, but the first time you do it, it's going to be painful. Right? And then we need to say that it's a dip trace one. It'd be nice if it auto-completed that a bit. And we need to have a manufacturer and part number for it. I don't know. Let's have a look. So previously in my list of things that I did, well, we might be getting into substitution land at this point. Let's see. Right. So what do we want to do? What are we looking for? A 10 nanofarad cap. Where's a 10 nanofarad cap? Right. But the thing is, this 10 nanofarad cap is a 50 volt one, not 6.3 volts, right? And it's also got the dielectric material specified, X7R, right? So it's not really appropriate for this. I mean, this isn't. It wouldn't be appropriate to use that manufacturer part number for this specification. So what we want to do is say wherever you see a 10 nanofarad 6.3 volt 0402, use the 50 volt X7R one instead. So we need to do a substitution. We wrote some code for doing substitutions, and there's a command line argument, I believe, for doing substitutions. So if we do the help for this thing, build -- help. Right, we've got this substitutions, and then we've got a source, and you can have more than one. You can have more than one substitution. So we're gonna go substitution equals /project/ global. Well, I suppose they're in that directory, so they're global enough. Let's say substitutions. Right, and it's going to go, no, can't find a file. We've got a nice message, so that's good. We did that yesterday. So let's make a substitution file. What does a substitution file look like? I don't remember. Should we find out by putting the wrong fields in it? Let's try that. Let's touch it. Oh yeah. And then run it again and see what it says. Well, it says no matching parts. There's no substitutions. There's nothing in it for it to fail with. So I don't know. Let's put something in it. Not that program. This one. Substitutions. Kaplop. Don't really know what's going to go in here. So if we just go foo and bar and run it again, see what happens. Nothing. There's no problem. Okay, we need to know what the substitution file looks like then, really, don't we? Substitution record. Oh no. We've got the same problem. This one uses sudo flatten as well. Oh, okay. Maybe I don't need to fix it right now because we're not substituting the part that's got a string which is only a number. So I'll fix me. This is broken for fields that only contain numbers. But we're substituting a capacitor for another capacitor, and they've got alphanumeric digits in it, so we should be okay. But I'll fix this. Don't worry, I'll fix it. I'll fix it in the same way. So that's why it doesn't complain about anything, because it's just got all the fields and it's fine. So we're supposed to have a EDA field. So let's add an EDA field. So EDA. Don't do that. EDA. And then it's got a name and a value and a name pattern and a value pattern, I think. I think that's what's supposed to be in here. Let's refer back to the substitution thing. We go build substitution, and we're looking at name value. The transforms are what we're interested in, so we need to create a oh yeah, underscore pattern, yeah, right. So it's the for each field name, yeah. So for each field name, you have the name of the field, and then you have another one that's underscore pattern. Right, and we use upper camel case, which is fine. So yeah, I was right here. We're good. So here we're going to go dip trace, and when we see cap 0402 with value, no, we'll do this the other way around. When we see this name pattern with this value, then we substitute it for a cap 0402 and a value of something else, which is going to be the thing that we have a part for. So we're going to substitute it for this one. Okay, right, and that means we need a part mapping for this. So in the part mappings we go fine. Yeah, that's weird. Why is it? Oh yeah, we were doing it. So we don't have that there. Do I have that there? I do. Oh dear. It's all going pear-shaped. Let me go back to this. There we go. So when we have this part, then the manufacturer and part number need to be part code and MPN. This one, but the other way around. Like that, right? Like that, right? And let's see if this works. Found a record with 5 fields, but the previous record has 6. Not this file. This file. Too many commas. There we go. No matching part. Right, so we've got a part mapping, but we need a part. So we're going to schlep this in the parts. With the quotes? Who knows? With or without quotes? I don't really care right now. I could just load it into something else and save it all with quotes at some point. We're just going to ad hoc it and like a human until things say no. There we go, look. So C1 is done. So it says it's going to be this part because it substituted this because of this pattern. It substituted this with this because of this pattern. And therefore it picks this part. Yay. We're good. And look, it did this other one as well on the other side of the board. So we're good. Fewer things to do. Okay, cool. Okay, let's do the next one. 100 nanofarads. Let's go in the substitutions. Oh. And when we see this, we're going to substitute it with something more specific, because it doesn't say the rating on here, right? And we've probably got some other ones available. So we're going to go 100 nanofarads. There's my list of parts. Well, it turns out we actually have a couple here. Now you see, decisions. We could substitute it for the fancy waltzing one. Should we do that? Let's do that. Right. So then we need a part mapping. For this. And the part mapping is going to be the same manufacturer, but a different part code. Which means we need these in the list of parts. Like so. Okay, that's not too bad, is it? Once you get the hang of it, you're all good. Well, I'm not sure about that. Okay, so it's done the 100 nanofarad cap. This is interesting, this one is, because this one says 100 nanofarad 6.3 volts, and then we've got some other ones here, 100 nanofarad 16 volts. So we probably could go back to the EDA thing and then update it so that it uses a 16 volt where it's currently got 16 volts. But if the schematic was using like a module from like, you know, a library of like modules that you use in your schematic, you wouldn't necessarily want to do that, because that would then obviously have an impact on all the other designs that use that same module. So we'll continue with the with substituting things, not this file, which, where are we? This one. We'll continue. So where we see gap 0402, this one, we're going to say it's going to be this one, right? 50 volts, 16 volts, everything's fine. X7R, 10%, 10%. That'll work. Okay, so if we run it again now, there we go. So now it's substituted load more, loads of them done now. That's good. Let's look for the next error. Here's one. Error, no mappings. So we're interested in fixing this one. 2.2 microfarad. Let's have a look in the part mappings. My old one, 2.2 microfarad. Yeah, very good. Yeah, okay, we've got one of those. So in the substitutions, dip trays, where we see the cap 0402 with this specification, we replace it with something of this specification. There we go. Like so. And then we need this in the part mappings. And then the part that we need is Murata. Too many files. Murata. And then this one. And then we need this in the list of parts. There we go. Let me reorder my tabs. There we go. Substitute part mappings parts. Okay. Run it again. Okay, that worked. So now we've got this one. Oh yeah, this is this part's well good. F98s for the win. Okay, so now this is going to be slightly more involved, this one. Not too much though. 4 volts. So let's see. Yeah, we've got it. Cool. Cool. Substitutions. That's what we want. Well, I don't know. We're not actually substituting that. This is just a part mapping. Where we see this, we want this part by this manufacturer. There we go. Run it again. Look for the next error. Oh, it's because we didn't add it to the list of parts. Why didn't you tell me? Why didn't you tell me? Run it again. Wow, this is looking pretty good, isn't it? Oh, it's not too many. Shall we see if we can ignore the test points, right? Just to clean up some of this extra verbosity as we've got, you know, all this stuff. TP ones. Can we ignore things? Do we remember how we ignored stuff? I don't. Variant builder. I'm pretty sure we had a test for it somewhere. Let's bring up the structure. Ref des disable list. I mean, are we just disabling them or are we ignoring them? I suppose TP 1 through 13. I mean, they're still here, but they'll be disabled. Fine. Okay, we'll ignore those for now. Okay, next one. 1 microfarad. Oh, this one's actually got a rating specified, isn't it? That's nice. So we can just use that. No need for substitutions. Right, and what we using? We're using one of these by Murata. There we go. Run that. Oh, what happened there? Oh yes. Add it to the list of parts. There we go, done. Then we got this one. Yeah, it's not too bad, this. I mean, I've got this big database of parts already, you see, so... I've got 1.5 picofarad, 50 volts. So we've got to substitute this one. This is what we're going to substitute it to. And we're going to substitute it from something that's a bit like this, but not exactly. What did we say? 6.3 volts. There we go. So if we see a 6.3 volt, we substitute it for a 50 volt one. Cool. Then we need a part mapping. With that. And this is made by FH. Thus. And then we need a part for this, which goes in the list of parts. Yeah. Too many windows. There we go. Right, cool. Done. Right, now we've got another one, very similar. 1.2 picofarads. Pretty sure I ordered 50 volt ones when I did this. Yeah, here it is. Stick it in the parts. Done. Run it again. There we go. 0402, 100 nanofarad, no, that one, this one. 1.2 gets replaced by a 6.3 volts get replaced by a 50 volts one because of this. And the part number is different to the other one. Perfect. Alright, 10 mic, 16 volt. Let's look for that. I know there's a substitution for this. Shall we do this by doing this? Yeah. Okay, so when we see this, we're going to replace it with something else. Oh, it turns out I've actually got these. Okay, fine. We don't need a substitution then. Fine. We'll have a part mapping then. Samsung. Alright then. And then we add it to the parts. Go back to this, run it again. Oh. What did I do? Oh, because it's 0805. Duh. Oh, we're getting there. We're getting there. There we go. Dunsky. 1206. Alright, we've got this. Now, of course, if you didn't already have this list, right, this process that I'm doing now would obviously take quite a lot longer because you'd have to build this list by looking through your part inventory, right? This is one of the time-consuming parts when you're going, when you're starting to do assembly, because you need a list of all the things that you've got somewhere that you've got to search through in order to build this list up. But at some point, I'll stop looking at this list when I've transferred all of these part mappings to this new system. At some point, I'll stop looking at this list. And then the only place they'll be will be in this list, right? And then maybe I'll stick it on Google Sheets and then have a Google Sheets URL as a source for this, right? Because at the moment we're specifying a path from the file system, but with Google Sheets you can copy this link that you get from this and then use that as the source. It's possible to do that, if you didn't know. Right, anyway, moving back onto this. What's the next one we're doing? It was this one. Wasn't I already there? I was already there. Right. So we're just doing a part mapping. Dip trace. Oh. Maybe I could reorder some of these things to make this a bit less typey right now. But I'm not going to do it. Uh-oh. This is backwards. Maybe I will. Look, maybe what I'll do is temporarily... which one can we reorder most easily? Does it actually make sense to go from the name of value to the part code of manufacturer? Name, value, part code, manufacturer. Can we reorder these? Can we move it right? No. Okay, so instead of reordering this data, we'll reorder the source data. So we've got manufacturer, part code, name and value. And now I can just copy them all out of here if I see them. Fine. Sure, everything's fine. Okay, let's run it again. No, we didn't add a part. Let's add a part. Is this one right? Yeah. Okay, 220 nanofarads. Let's have a look for this one. There he is. Oh, don't do that. So we can copy all of this out of here. And then ideally, we can just go into our part mapping. Let's place it in there. And then put quotes on things. Oh no. Sent quotes, okay. Right, again. Right, we don't have a part. Keep forgetting to add the part. It's interesting that is actually, because couldn't we do that automatically? Like, if you add a part to a part mapping, it's not in your list of parts. Like, just add it, right? I'll make a note. Let's make a note. Let's add it into here. Ideas. Add parts from part mappings to parts. That'd probably be quite useful. Might save a little bit of time. And perhaps you can say, give me the list of parts that don't exist in the parts thing. Here's the list. Do you want to add them all? Yes. Okay. Done. Or no, don't add these ones. You know. Or make corrections. Run it again. Do it. Probably be useful. Okay. Running again. We're getting there. Assembly variant. I mean, this is good for the ELRS project because this is work that I would need to do anyway. This is to enable me to carry on building these receivers that I started making, for which the dev team is still waiting for. Look, PK, look, I'm working on it. Don't worry, everything's fine. It might take a while, but you know, we're getting there. We're getting there. Alright, next. This one. We're slowly getting through it. The end is in sight. Right, so we've got a part mapping for this. I mean, I've built these already, so I should have part mappings and parts defined for all these things already, so it shouldn't be too bad to convert this over. I don't want to type those characters again. Okay, and then add it to the parts. Parts, blop. Mappings, back to this, run it again. Doodly doo. Didn't I just add that? No. Look, we need a substitution. Do we? What? Wait, what? 47 microfarad. Oh. Wait, no. 47 microfarad, 10 volt, 1206, x5r 20%. $12.06? Oh, it's because it's got this pattern here. Okay. Right. So this pattern is, it's actually just a 12.06. So here we're going to get a bit funky. So when we see this, we replace it with $12.06 like this. I think we're missing a quote. Yeah, there we are. Okay, so now it's to substitute it and then map it, right? Yeah, there we go. So yeah, good. Right, next error. Here's the next error. So we've got another 10 nanofarad one, but it's 25 volts. Look, 25 volts. So we're going to say, when you see a 25 volt one, slap in a 50 volt one. Alright. Bomb reduction. Let's go. Okay, next error, this one. 470 nanofarads. Do we have a part for this? Yes. Part mappings. No. And then add it to the parts. Come on. Why is my cursor not working? Okay, now it's working. I don't know what happened there. I think I pressed a key accidentally. Parts, parts, parts. There's parts. One again. Now what? Right. We've got a diode. We've got a diode to do. Let's have a look. Well, right, so bear with me one moment while I open up my other file. There we go. This is my old substitutions file. So this is what we do. We say, when you see one of those, replace it with one of them. Yeah, like that. And therefore, this part should be in the list of part mappings. And that's what we're going to use. Part mappings. And it's made by these people. And it's that. Yeah. Okay, we're gonna carry on until we have another reason not to. Because in my old substitutions list, I don't know whether anybody noticed that, I had a I don't care what the value is expression, which I should probably be using here as well. But is this... I'm going to leave it blank for now. Until I know I need it. And then we'll come back and edit it. Right, did that map the diode? Yes, there he is, look. That's cool. We've got a feed-through cap now. Ooh, they're exciting, they are. Yeah. There's our feed-through cap. Add it to the parts. Plop, plop, plop. Run again. Feed through caps. Right, we've got some connectors to do now. Oh, we're getting there. What do we got left to do? A few connectors. 4 of those are the same, so that's good. And then we've got some inductors, some resistors, and some a resonator and some integrated circuits to do. We're getting there. We're getting there. We've done most of it. We're getting there. Look at the stats now. The stats is good, isn't it? Look at this. 80 replacements, 9 substitution rules, parts and part mappings. Yeah, pretty good. Pretty good. Alright then. Ooh, the mezzanine connectors. They're exciting, they are. I like the old mezzanine connectors. Why don't I have a part for that? Is it in my substitutions? Yes. Yeah, there's like ordering code differences and height differences because my design specifies like one height, but they didn't have that in stock, so I had to order the next highest one. So yeah, a substitution. So where we see one of these, we replace it with one of those. Okay, so that means there should be a part mapping for the one that we substituted it with, which is made by High Roads. And I know I need this other one that's next to it, so I'm just going to grab both of those for now. Because this design uses both of these. That ain't gonna work. So we've got a part, a name, and a value, but we're missing a quote. Look. Yeah, like that. So then we need these 2 parts in the list. Alright, let's run it. Yeah, so it did this one and it did the other one because I knew we needed it. There it is. Right, now we've got this one. Now this one's a bit funky. This is a through-hole part. This is a through-hole part. But for the design variant, it doesn't make any difference. Only when we come to do the workflowy stuff that it actually makes a difference. Okay, so let's see if we can find that. Why is it in red here? That's curious. Probably because it needs to be substituted first. Yeah, I don't know why. I don't know why it's red. And see, look, I've got some notes here. See through hole. Right. So yeah, part substitutions. Kablop. So where you see this with an empty value, put in this one with also an empty value. The fuck is going on? The drivers are shouting at each other outside my window. My house is on like a corner of a sharp corner, and sometimes people come around it too quickly. There was squeaky brakes and everything then, tyre marks, tyre screeches. What are we doing? So we're doing a part. I know that. No, not that. Okay. It's not very exciting, this, is it? If I was playing this stream back, I'd probably skip forward right about now. You guys are so lucky you don't have to sit here and do this. So where we see this with a... Yeah, that's right, yeah. So this is the part, manufacturing part. Okay, great. Couple up. That should do a few more. Yeah, there we go. Okay, J7. What is this? What is this? What is this connector? Oh, I know what this is. Yeah, this is the Rev B. I should be doing Rev A's. I haven't got this part. I did buy some. Let's add it anyway, because, you know, maybe at some point I'll add a Rev B. Fine. So we're going to need to find out some details for this. So, yeah, what do we want then? We want lcsc.com, probably. This is where this came from. It's one of these. I bet you guys haven't seen these parts. They're pretty small. So, this is the part. Alright, so let's stick it in parts. It's made by these people, X, whatever, who's a Fujimi blob. Right, so therefore in the part mappings we need a part mapping for it. Right. And when we see this name of value in dip trace, then we have to use that. The name of the value that we saw in dip trace was just this. Right. So we get. So that's what you do if you haven't got any data prior to doing this. Ta-da! It's done. Right. Right. Right, so we've got some inductors. Okay, so 1 microhenry. Let's see if we can find that in my list of stuff. Oh, we do. We've got this. Okay, then. So you got a microgate. Alright. Add it to the parts. Plop. Go. L1. this one next. Oh, it's these ones. I know we need this one as well. So let's have a quick look at this. We've got the 2 nanohenries. We've got the 2 nanohenry ones. This one. Not that file. This one. Part mappings. No, 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 come back. All is forgiven. My alt tabbiness was a bit... My control tabbiness was a bit alt tabby. Try again. Who's next? Error. Oh. Hold on. What happened there? 2 nanohenries, 400 milliamps. Right, so this is a 500 milliamp one. So there needs to be a substitution for this 500 milliamp one. Oh. Oh, okay, different part. Fine. Okay, well that one's in there now anyway, fine. This design doesn't care about it. So look at this. Over-specified parts on the SP Racing products, check that out. Design requirement for 400 milliamps, but what you get is a 900 milliamp one. Maze balls. Alright, so let's find that one. That's what we need. Okay. Oh. From the same range these ones are. That's why I was confused. Why have I got that specified the wrong way around? Let's fix that. The inductance is the most important thing. There we go. Right. Now what? Let's have a look. 1, 2, 3. So he doesn't know what this one is. We're getting there. We're getting there. Not too many to do. It is tedious though. Oh, such is the life of PCB assembly. Sunlord inductors, pretty good. Good value for money, those ones. Quite reliable as well, no problems with them. Oh, I see. Right, so this one has got any value because it's already got the part specified here, right? So we need to get a bit more creative here. So when we see any value, it should do the mapping. Well, that didn't work, did it? Why not? Right. So, should the part mappings support regular expressions. I'm not entirely sure, because the way to fix this would be to say that whenever you see this, hold on, whenever you see this, replace it with this, right? And then in the part mappings, you don't have that. Not entirely sure yet. I'm going to put it in my list of things. I think it's already in the list of to do anyway. Support regular expressions in part mappings. It's on my list. Then we should be able to delete that at some point. Let's see if it worked. There we go. So now it works. No, it didn't work. Why not? What's going on? Why didn't that work? So we said when we see this, replace it with this. But is that what we actually had? Yeah. Why is that not working? And we've got it in the parts list, right? Yeah. Did we not add the regular expression support to the substitutions? Maybe we didn't. I think it's currently an exact match only. Okay. Somewhere we need regular expressions. So to continue today, we need to put this in here. But what we really want is this. And then at some point this will cause an error for me, and then I have to come back and fix it. Probably. Right, let's see if it did it now. Yeah, see, now it's done it. Yeah, so we need to do the regular expression support still. Everything's fine though. So we'll do the same with this one. And this regular expression needs to be, you know, exactly that. Quite whether we're going to have to come back and escape these things, I don't know, you know, because this isn't a regular expression, but it's got characters in it that would be regular expression characters, which is why in the PnP convert there's a way of spotting a pattern if it's inside a slash and then a ending slash, right? That's why it's like that. So we need to come back and poke this around, but we're okay. So we need to add support for this part. There he is. That's what we're going to add. Alright. Okay. Q, we're on to this one. Great. Yeah, it'd be nice to have the regular expressions. And I'm just going to put in this value for now, and then if I've got another design which has a different value in it, then I'll change it to a regular expression as and when. Oh yeah, we've got to add the part. Okay. And probably there's a way of getting a list of all these things out of this, but not very easily. What would make this quicker? What would make this process quicker? I guess having a list of all the names and values in a format that you could just copy and paste into a CSV file. Let's make a note. I mean, really, there'll probably be like an IDE for all this kind of thing at some point, where be able to click on things and import parts from inventory and all this kind of thing. So, don't know about that one. It's probably not that useful. Into part mappings CSV file. Sorry, EDA tool specific that is as well. Okay, so what's the next one? We've done that one. So we've got a few resistors to do. We've got about 12 or so parts to do. Some of them are repeated though, so it should be alright. Alright, let's do the 10k resistor. $10k 1% 50 volt. There's two. Oh, look at this. Oh, this one's going to be fun. Right, so we'll copy both of these. This is where we're going to actually have to do an assembly rule in a minute. This is good. I was hoping there would be an example of this. So because there's going to be multiple mappings found, right? Maybe. Let's see. There might not be, but we've got options. We could pick either of these two resistors right now. So in order to choose which one, we need to look at the other ones and see if any of them say a high voltage rating already. So no voltage rating 10k, no voltage rating, no voltage rating. So we're free to pick whatever. I know the design is for low voltage sources. So let's look at this. So they're both 50 volts, they're both 1%, so fine. So what we're going to need then is a substitution that goes from res 0402 with a 10k 0402 1% with no voltage rating to a 50 volt one. And that's what we're going to do. Same as we do for the caps, right? Right, so that fixed a bunch of resistors, that did. And look here we go, look. Error. Unresolved mapping. So there's two we could choose. So now we've got to fix this. Yeah, good. So we've got rules. So if you remember, I'm looking for the command. Come on. Right. There was an assembly rules argument. And we're going to need it. And this is going to be what? Projects, and then it's specific to this project that we're doing, and it's specific to this design, and we're going to say rules. Right, and it can't find this file because it doesn't know about it. So we're going to touch it. Great. So now we've got a file. There he is. And we're going to try and remember what goes in here. I don't remember what these are at all. I have no idea. I can't remember. Assembly rule record, what did we say? So we say when we've got this particular FDES, this is the manufacturer part number that we want to use. So the file is refdes manufacturer MPN, right? And for this one, it's well, there's quite a few of them. R1, 3, 6, and 101. And they're all going to use there might be better ways to do these rules now that I'm thinking about it. Let's use the Jaeger ones. Now if we gave it a loadout, right, and the loadout contained this, it would be done automatically, which might be better. But you know, you're allowed to change your mind when you do all this. Let's see what happens now. Matched assembly rule. Ta-da! Fixed. Okay, so now we're on to this one. So when we see 100k 0402 1%, we replace it with the 50 volt one. Sure, why not? I don't know what the manufacturing part number is yet. Let's see if we can find out. 100k 10k, 100k. Okay. Oh, that's interesting. Oh, we can do better than that. Let's look up this part. What is it? What's the specification? Has it got a voltage rating? No. Maximum working voltage. It says maximum working voltage. What about the minimum working voltage? That might be a bit more useful. Or is it? Oh no. Okay, so they're all 50 volts. No, it's fine. It's fine. I'm thinking about something else. Do you want to visit this website in Spanish? No. Go away. Okay, so it's a 50 volt one. So we're going to borrow this. Stick it in the part mappings. Well, no, we did it already. Multicom Pro. This part number. There we go. All right. So it turns out that's a 50 volt one. Is it 1%? It is 1%. That's good then. Alright, run it again. Oh. Nearly there. We're getting there. Let's have a look. This one. Next. Oh, look, that's interesting. 5%. There's already one in there, so that's fine. We don't need to do anything with that, I don't think. Don't forget to add it to the parts. Yeah. See, if the parts source was like an inventory database, then yeah, it would just find it if it was there, and then if it didn't find it, you could have some auto get thing which went to the suppliers and tried to find the part. Okay. Right, but this doesn't specify the voltage. It was a 5% 50 volt, wasn't it? 5% 50 volt 470R. Yeah. There we go. That's it, that did it. There it is. 10 ohms. So we've got our part. Add it to the parts database list, whatever you want to call it, and then we're going to add a substitution for it, which is whenever you see 1206 with this, you get you should use this. There we go. Go. Okay, did that do it? No. Oh, it's 0805. I thought it was a 1206. And I screwed that up anyway. It's fine. Right, do it again. Right, okay, what about now? How about now? 0805, that's done. No. No mappings found. So we've got a substitution. Wait a second. Oh. Wait, what? This is 0603. And this 0402. Where's my other 10 ohm ones? Wait, what? Oh, it's there, look. Okay, fine. Oh yeah, I used some fancy ones there. Alright then, fine. That's the wrong file. We have to put something else in there. Okay, so we've got a KOA spear, fancy green resistor, and this is what we want to say to use when we come across that here. Okay, now, how about now? No, because I forgot to add it to the parts list yet again. Okay. KOA spear, there we go. Done. Whew. Okay, 24.9K, 0402. So, let's have a look. Ah! Don't do that. It's not got a voltage rating on it. This is in the part mappings. Okay, we can do better than that. So we'll tidy this up as we go along, you know. So this part has a voltage rating. Right, but we need to know what it is. Let's look it up. Yes. Voltage rating, 50 volts. So, when we see this, we replace it with this. Okay, and then we need to put the part in the list. And run it again. Okay, so we've done the resistor, great. Yep, okay. So now we're looking for this one. Okay. This is a button. It was a really strange coincidence with this button, right? So, you guys know that I do drone stuff, right? So, I'm looking for a part to put on my tiny little micro receiver, and you know, there's like 1,000 tactile switches that you could possibly pick, right? And I find this one. It fits my requirements. I'm like, this is great, right? LCSC do it. It's this thing. It's very small, right? But the manufacturer doesn't provide a 3D model. So I go 3D model and then this part number. And then, you know, there's a bunch of them in a different format. And then I end up on, like, I think it's this site, GrabCAD. Who recognises this name? It's such a small world, it's hilarious. Alex Fedorov is the guy that makes the KISS flight controllers, right? Not this guy, though. Alexander Fedorov. KISS flight controllers. This guy. So, you know, I make flight controllers and stuff like this. I look for a part. It turns out that another guy that makes flight controllers looks for a part, and we end up using the exact same one. Oh, lovely little coincidence. So funny. All right, moving on. It's hilarious, that was. I was like, no way. Right. Okay, let's add this to the list of parts. The reason I like that one is it's because it's got a reasonable level of dust proofing. It's very, very small, and it fitted my design. Oh, and it was cheap as well. Bonus, that was. Okay, there we go. Right, so we've got a bunch of test points which we don't care about at all. Okay, so all we've got to do now is this list. Right. Okay. These should be fairly painless. What I'm going to do is search for each of these and then edit them all at the same time. Oh, that's the parts list. I don't want parts. It's part mappings. Duh. The next one was this. Well, this one's slightly different. Let me search for this. Come on. No, not that one. This one. Yes, there's two of these. Don't know which one we need, but we'll take both. They're both the same. Yeah, we've got regular expressions on this one. Yeah, it'd be nice to do the regular expression support. And the last one, this one. Okay. see if we can make this work. So delete, quotes, quotes, end of line, beginning of line, paste, comma, quotes, maybe? Probably do it. Right. But we don't really support regular expressions in here yet. It'd be nice to fix this so that we do. Let me put that one back on for when we do support it. Let's put it in the format that we want for now. I'll copy this one. Because we need what we've got now and what we want for the future. That should probably do all that. But the expressive one needs a substitution, because those of you that were paying attention would have noticed that this says split under the end of it. And there is a reason for that in the EVA design tool. Substitutions. So where we see this, we replace it with this. Right. Okay, let's run it. We've not added all the parts. Let's do it. That one. Can we do it? Can we do it more clever? We probably can. No, not very easily. No. No. No, I don't know how to do it. It'd be nice to... I could probably do a regular expression. Fine, we'll just do it one at a time. I want to be able to select the next comma, on each line in order to select it up to the right point. Okay. Last one. So hopefully the design variant should be complete when we run this now, unless there's any more errors that we need to fix. Okay. So we're looking for errors here. Right, it says mapping failures, but you know, it's okay. I suppose we need to... What do we need to do with this test points? Because we've got a name and a value of nothing. I think we need some way of handling like test points better when we're creating these design variants, so that we can I don't know, maybe we can Maybe we can have like an assembly rule that says anything beginning with TP just ends up going to like a test point. But a test point doesn't have a manufacturer and part number, right? So this is the thing. Yeah. I'm going to dwell on that some because the test points are a bit weird. Better handling of test points when creating design assembly variants. What MFR plus MPN to use, or how to handle ignore. Yeah, okay, so that's on the list. Okay, so everything is mapped, so it's all good. But now we've got this error. The system cannot find the file specified. So I think what's happening here is that in the code where the variant builder is trying to write the CSV file and then read it back in, I don't know, is it that variant builder? What file is it talking about? So what does it do? It prints out the tree, right? Build mapping tree, and then it writes the tree here, and then it tries to write the CSV file. Now, for some reason, when I was specifying this a minute ago, I thought the output thing that we're supposed to specify was the name of a directory. But it's not, it's the name of a file. So if we say it's the name of a file, it should now be there, right? Here it is. Let's have a look at it. There we go. So this is our now normalized placements with manufacturer codes and part numbers there. Now we could add other things into this thing, like adding a description into it, for instance, which might be built from like the initial EDA source thing, perhaps. But I suppose you can look it up just using the refdes if you've got the original list anyway, and then you'd know. So maybe you don't need it. Okay, we'll go to the next thing. So right, where are we? Where are we then? We're trying to do this. So we've done this. Choose design variants, build design variants, assign PCBs to units. So now we use the other tool again. So we did that, and this was all good. I think what we'll do is copy that, and we're gonna create a new file somewhere. Oh, but Microsoft have just like removed creating text files randomly where you want them. New. You see, it doesn't exist on the list now. God, you used to be able to create a new text file with Notepad. But they've broken it. It's like Windows 11. It's just like, ugh, save as. I don't know why it's got that file name in there. Let's save it as a markdown file, right? We'll just create a markdown file. but it's got .txt on the end of it because Notepad's stupid. Stop it. Right. Then we'll slap this in the IDE as well. There we go. But this needs to be in backticks, doesn't it? Everything's fine. Right, so we've got that. Just so that if we need to do it again, we can go back to it. Okay, so now we need to go target debug, and we're onto the other tool now. We're onto the planner. How do we use the planner? Well, it's got a list of commands: create, add PCB, all these things. Right, let's do it. So we need to create a project. Let's see what happens if we just do create by itself. Use project specific command should be used. But I didn't use the project argument. That's not right. Yeah. This is because I want this name property, this project thing here. We've got a little bug there. I'm gonna see if I can come up with a better way of fixing that after this. We're gonna put it in the list. Bad error message when running okay. Oops, an AC. It's not really an idea, this is a to-do. Oh, that's interesting. Oh, it's got a... Oh. Maybe we can just have a Todo. Okay, you can tick it. Fine. I didn't know that it let you do that, but that's nice. Okay, so we've got that on the list. Okay, so we're gonna just ignore the fact that it does that and just say help like this. So you just create. Yes. We could definitely do better here, because what I wanted is planner create to tell you that it needs the project argument without repeating all the code and everything else for the project option. But I couldn't find a nice way of doing it. I spent a couple of hours trying to work it out and just couldn't find anything. And in the commit history, there's some notes about that as well. So anyway, what we're supposed to do is go project, and then we give it a name, but we also need a path. So what are we going to call this? Well, I suppose the project is this, right? And the path is going to be projects. That's interesting. Yeah, when you use the equals, it means you can't auto-complete. But if you do it like this, you can. So maybe we're going to review the usage of the require equals. Yeah. Requiring? How do you spell requiring? Anybody? Two more I's and E. R's. I use R's and E's. Project, and then this one. That's where we're going to put things. What happens if we do that? Unexpected argument project. Oh, I think it's because they're the wrong way around. Yes. There we go. That fixed it. So we created a project. Great. Now we need to add a PCB. Okay. So we're going to go add PCB with the same things that we did before and say help. And then say what does it do without help. Okay. Seems pretty good. So we're going to go a kind. What kind of PCB is it? I don't know. Is it a foo? Panel A, I suppose. Yeah, I mean, if I was placing two of these, then it'd be A, B, C, and D, right? Or, you know, that kind of thing. Kind foo, but I don't think foo is correct, so let's just see what happens. Possible values, single and panel. Yes, that's correct. We want to make a panel of them. But we don't. Because we don't really have panel definitions and so on just yet. So we're going to say it's going to be a single. And we're just going to go A. Name feels a little bit redundant. Maybe there could be a default name. Yeah. Okay. Consider adding a default name for a PCB of default, perhaps. Okay. Okay, so we've created a PCB. Fantastic. What's in our output directory? Let's have a look. We should have a project file. We do. There it is, look. Yeah. This is good. Then what? Assign variants to PCB units. We've still got to do that. Right. Let's see how we do it. So what we can do is assign variant to unit. Can we do? Oh, it doesn't autocomplete. Assign variant to unit. It needs the design name. And then it's going to try and load up some placements from a file. I don't remember the exact format that I was supposed to use for this file. We're going to find out in a minute. I think I should have given this a different name here. Yeah. Okay. Let's say the design is this, and the variant is default, and the unit is going to be single. Well, it's first single unit, and it's the only one on that board. It seems a bit redundant, the unit on a single. It makes sense for a panel, but for a single, a bit less so. Add unit equals 1 to a unit path for a single PCB automatically. Something like that. But I think that's what we need to do. Now it goes unit assignment added, which is good, but then it said the system cannot find the file specified. Now this is because it's trying to load the placements for that design variant that we just created, and of course the name of the file that it's trying to use doesn't match the name of the file that I created a minute ago when we created the design variant. So we need to try and work out where that bit of code is and improve the error messaging, like we did the other day, yesterday, for the other stores. So I'm not sure this placement should be in the stores. I don't know about this yet. Let's have a look at our placements file. Yeah, this isn't EDA placements at this point. Okay, so the planner. Planner. This one. So the thing that it's trying to do is assign variant to unit, and it loads the project and updates the assignment, and it goes okay. So it did that, and then after that it's supposed to refresh the design from the variant, and as part of this refreshing, this is where it loads up the placements here. Right, and this is the file that it's supposed to be using. So I was sort of close when I named this file, but it's supposed to be _default _placements, like that. But we'll just quickly undo that because we want to see the error message. So this bit here is where we need to improve it. So we've got this planning placement thing, and in the stores where we loaded up some part mappings, we improved the error messaging like this. So we'll do the same thing. Right, and then we're going to need this with context thing, but it needs to be placements path. Right. What do we do here? Should this be an anyhow error, or should we be mapping the error? Oh, no. I see. I don't think we should be using the implementation details of the CSV library that we use in the signature of this method anyway. So it should probably be one of those, right? Okay, so let's go back to this, and apparently it was okay to do this. Right, but it's passed in, so we have to clone it here on this one. Oh, hold on. Do we? I think we have to clone that one. Right. Yep, okay, fine. Make sure everything works. Yeah. Oh, right. CLI. Okay, we're good. So, what are we doing here? To do report errors. Well, this is a bit different from what we had the other day. Let's have a look. Well, we fixed today's problem, but we still don't have the report errors done. So this one works differently to the other ones. It doesn't have that bail thing, and we're not using the question mark operator and all this kind of stuff. So it's a bit different. So it needs a bit more thought behind it. So I'm going to leave that for another day. So we shall continue running this. So now it says it can't find the file. So this is what we should have used here. And the command that we should have used to do it should have contained that on the end of it. Right. So now what happens? So there we go. Wow. That was good. It's quite noisy. Part changes. Yeah, okay. Part changes and placement changes. So this should probably be like debug or trace logging these ones. Let's see if we can find those. Right, currently it's on info. Let's make that debug. And this one as well. We need to do a commit. We need to do 2 commits. This is the first one. This is not amending. Improve error message when loading placements file. And then this is where we just okay. Fix star whatever foo. This is some other changes that should have been in a previous commit where I forgot to press the amend commit button after making the changes. Then what else have we got in here? We've got I'm not going to push these changes. I'll probably fix it and then squash this commit, but I just want to get it out of the way for now. Right. Right, and then in the planner, we'll change logging levels of part and placement changes. Okay. And then we're going to run everything, which will rebuild the executable. And we're going to, I mean, if I run this again, I'm kind of curious as to know what happens, because the assignment's already been made. So previously, it said, well, the first time I ran it, it made the assignment and then failed to load the placements. The next time it ran, it added a unit assignment and then loaded all the placements and so on. So it's possible now that the project file contains 3 assignments for the same thing. There may be issues that we need to fix there. Let's have a look. So the project file, no, we're good. But it's printing out the message when it shouldn't, I think. Was the message the same every time? Or did it say updating? I don't remember. It said added, added, and added. So that's not right because it's not adding it. So we'll have a look at that. Something like that. Was it unit assignment added? Okay, we recorded that. Okay, fine. Right, so this is good. So it's got new placement and it's decided that they're all new. Then the second time you run it, none of the placements should be new. And it should update them all. And that seems to be the case. This is good. This is good. So let's have a look at the project file now. So we've got name, processes, pick and place, and manual, which were the defaults. We don't currently have a way of specifying the processes. Probably need to fix that at some point. Yeah, okay. Let me just add it to my list. Yeah, okay, captured. Right, so PCBs, single A. Everything's fine. Unit assignments, this one to that one. I'm just making one. Part states. Well, this is the test point, you see, and it's yeah. Yeah. I think we need better handling that. It's not technically invalid, but it's not very good either. Right, so it's basically got the list of parts, and it doesn't know that none of them have been assigned to a phase yet, so that's fine. This is all the parts, and then we should have a list of placements, and this is where they go, and it's got all the things. That looks pretty good. So we've got our real-world example of placements and parts and everything. Right, so what's next? Assign variance to PCB units done. Create a phase for each process and choose loadout for the phase. Okay. Who remembers how to do that? Not me. Create, add PCB, assign variable to unit, assign process to parts, and create phase. Well, okay, let's go. What do we say we need to do? Yeah, okay, fine. We're going to do create a phase. And we might think about reordering this help. Create a phase. How do you create a phase? This is what you do. You go process, and we're going to go manual. The reference is going to be top. Yeah. PCB side is going to be top. For now, it's top. Let's say top 1. Because if you added another phase for the top, it would be called top 2. But you know, you could rename your phases, right? Screw it, top it is. PCB side, top. And then loadout. Loadout source. So this is going to be projects loadout. Let's say, well, because we're doing this manually, we don't have a pick and place machine involved. So we're going to create a project specific loadout for this. Manual loadout top. Seems reasonable. Boom. Okay. Let's have a look at the project. Plop. What happened? Here we go. We've got a phase now. That looks good. Okay. And then it says assign placements to the phase. Add the placements part to the phase's loadout. Both those things happen at the same time. So assign placements to phase. Assign placements to phase. Phase top placements. Well, now when we were doing the first cut of this, right? Yeah, this messaging could be improved. Like, what's placements? I mean, it's a regex, but regex on what? Yeah, we could do better, couldn't we? Because if I can't remember now, it's not going to help anyone else. Let's have a look at the command. what do we say? Assign placements to phase. And it says placements. What happens with this placements? Placements pattern. I mean, placements pattern is match. Let's have a look. No. I mean, it's a regular expression, but what's it? Oh, it's the unit path, isn't it? Yeah. Okay. I remember now. Okay. Let's right. There are other ways that we want to do this, but we're going to use the object path for now. Placements, object, path, pan. Right, that will have broken the test. Right, so what we're supposed to be specifying here is a regular expression. Now, I want to place all of the components that are on the same PCB side as the side I've chosen for the phase for this phase. So that should work, right? Something happened. Okay. Okay. So now let's create another phase for the bottom. Create a phase. And then say bottom. Bottom.csv, which should create a phase. And then we're going to go assign placements to phase, bottom. And then all the placements again. Okay. And now let's review. So, okay. So there's some components which went to the bottom. So we've got a Pico D4 on the bottom. And I know that is correct. Here's the design that we're looking at, and that's the bottom. And the Pico D4 is in the middle there. So that's good. And let's go to the top, the previous one, and this crystal is here, is there, which is on the top. So that seems to have worked. So yeah, so we've assigned a bunch of things to loadouts. Okay, so we've got loadout files now. This is good. We're getting there now. Look at this. Oh yeah, like this. So this is our loadout for the top, and they've not been assigned a feeder, which is correct. And here's the loadout for the bottom. I think we can do a commit as well. Let's just do the commit real quick before I forget. So we basically improve the messaging. Yeah. Yeah, right. Cool. So we've got two loadouts, one for the top and one for the bottom. So when you're placing all your parts on your PCB, you go to your parts behind you and you get that list of parts. Happy days. And you put the bags on your desk and away you go, and you're ready. This is good. We do have the test points in here still. Definitely need some improvement there. Okay, so yeah, so far so good. So assign placements to phase, add the placements part to the phase loader, which is good. Let's have a look at the project file, because we did some things, but we've not done this assign process to parts. Did that happen automatically, or what? I don't remember. You sit here writing all this code and you just like focused on all the detail of all this, and sometimes you forget what you've even written, what you're supposed to be doing. Okay, we'll have a look at the project file. So the project file, here it is. We've now got 2 phases, which is good, and we've got these parts, but they don't have any processes assigned to them yet. I think we need to do that. Shall we try, at this point, generating the artifacts? We're just going to skip ahead to the end, because, you know, this is sort of what you want to do. Generate artifacts. Let's just try generating the artifacts now and see what happens. So, we're going to do this, just to see what happens. I don't know. Are there any arguments for this? No. Generate artifacts. Oh, here we go. Let's just see what we get, because we should have a bunch of issues, right? Generated artifacts. This is good. And it's detected some issues. Good. Right, and now we've got this report file, which is what we could use to generate an HTML thing. So we can have a sort of, at some point we need the JSON to HTML converter thing, right? But if we're building a UI, maybe we don't. Okay, let's have a look at this. Here we go. So let's go to the bottom of this, which is where all the messages are. We've got lots of messages. This is good. What else is in this report? So it says phase overviews. You've got a bottom and a top. That's interesting, because I added the top first and then I added the bottom. So I guess we need to like have some phase ordering. Let's have a look at the project file and see if the phases are in order in the project file. I think they should be. No, they're in this order as well. So they've ended up here in alphabetical order, which wasn't the order that I added them. So we're going to make a note of that. To do phase ordering. We haven't done it. Yeah. Okay. All right. So phase overviews, bottom and then top. Phase specification, bottom. Operations, what do I do? I get some PCBs out. Which PCBs do I get? I get a single PCB out. And this is the one that it is. That's what it's going to be. Cool. And then we've got some loadout assignments, but we haven't assigned any feeders to any of these things yet. So let's do that and see what happens. But let's see what else is in here first. So we've got loadout assignments. This is fine. And then we've got the other phase. And then we've got more loadout assignments, which is fine. And then we've got a bunch of issues. Yeah. Right, what else did it do? It generated placements files as well, didn't it? Yes. So here, where we said generate artifacts, was where it generated the loadouts. Loading loadout, generated artifacts. I guess it might be nice to say what artifacts it generated. Okay. To do. Show the file names of artifacts. Okay. These are the three things that it created. So we've got the loadout and then we've got the placements. So let's have a look at let's have a look at both of those. Top placements, bottom placements, top placements. There we go. So we've got an object path and it says we're putting this one on this single unit and it is the first one of that type. First one on that type. This unit on the single is a bit redundant, but maybe there's a better way of specifying it, but I don't know. Okay, and then it's got feeder reference, which are all empty at the moment. So obviously, for a manual placement, it doesn't really matter. You don't need feeder references because, you know, what's the feeder reference? Desk, workspace, worktop, boxes. I don't know. It might be, because I know inventory has support for saying where a part is in a building. So potentially you could have a list of like places where the part would be. Added there. I suppose you could query the inventory thing to find out where the parts was, but we've not got any inventory stuff yet. But just thinking out loud. But and then you could come up with like a feeder that's based on the location of the part in the building, which would be fine for a feeder reference, I suppose. Like shelves, tray 7B, right? And then you don't even have to get the parts out and put them on your desk. You can just get it out one by one when you need it, I suppose. It's a feeder, I suppose, isn't it? Human. Alright. So, feeder reference, empty. Manufacturer part number, XY rotation. That's enough to place some parts manually. I mean, yeah, we've got the ref des. You would need to sort of cross-reference an interactive bomb rather than using the X and the Y, but you could do it. You could go, I'm going to place A1, fine, and then this one, and so on. Okay, so, but these placements are in some random order at the moment. What order are they in? They're just in alphabetical ref des order, really, aren't they? Look, by the looks of it. So let's assign feeders and specify the ordering, because this is what we said: assign feeders and specify the ordering. So we're going to try that. Generate artifacts. We still haven't used this assign process to parts thing. So not quite sure about that. Okay, so we're going to try going assign feeder to loadout item. And then we're going to do what it says. So load out, and this is going to be top, and the feeder reference is going to be desk. And the manufacturer is going to be all of them, and then the MPN is going to be all of them. But you don't need the project argument when you're doing this. Is the loadout is a source. Okay, fine. So this is manual loadout top first, I suppose, and then we do the same for the bottom. Well, I suppose that makes sense. Manual placement feeder. Yeah, for a pick and place machine it makes sense. I mean, you can't pick without a source, right? But if you're a human doing manual placement, you can pick without a source. And you see, we've got this sort of rule here which says the patterns must match exactly one part, because the idea is that you have one feeder has one part, right? But is this true? Is this true? Like a desk can have multiple bags on it, right? And you can go into each bag and you can find the part. And the feeder is sort of like the desk. And you don't really want to go to the thing of saying like desk bag 1 or whatever, really, do you? I mean, that would be a bit silly to go into all this detail if you're doing manual placement for this. So perhaps either the rule shouldn't apply for a manual process, or it should never apply at all, but then that would be bad for a pick and place machine. But then you could perhaps detect it as an issue. This is interesting, this is. I just realised something here. So, currently, the assigning feeder to a loadout item was the odd one out for this planner. Right? Because it doesn't use the project. If you remember, I had to delete the project argument. And maybe this is the solution to the problem, right? Invalid argument project. Perhaps what should happen is that it should have the project still, and then it would fit into the other ones, and then all the help could be better, which would be good. And then, when you try and assign a feeder to a loadout item, it could check the project. You could specify the phase or phases, right? No, perhaps you just specify the phase and it picks the, if you specify the phase, it will pick the loadout that you're supposed to use for that phase, and you wouldn't have to re-specify it. You wouldn't have to re-specify the source to it, which would be good, right? And then it could check the type of process assigned to the phase, and then decide whether that rule applies. Yes. And then it wouldn't be the odd one out, and then it wouldn't have to solve that problem, and everything would be fine, and all the help would be better, and it solves lots of things in one go. So we're going to do that. Okay, so how do we write that down? So let's say assign feeder to loadout item. Okay, to do should take the project and phase arguments, use the loadout for the phase, and check the process for the phase, then make the changes. And we're going to say if the process is manual, allow the feeder reference well, I guess, yeah. There's two ways we could do this. One is like not apply that rule, right? And the other way is when you look for issues, show it as an issue depending on what the process is. But preventing the user from getting into a state to start with is probably more helpful than telling them to fix it afterwards. If the process is manual, allow the feeder reference allow the same feeder to be used by multiple parts, e.g. desk, and then let's say also to do detect duplicate feeder references in loadouts for PnP operations for phases with PnP operations. That seems good. That covers it both ways. Because then if you were to change the process used by a phase, right, then you would still have this, and it would capture it and say, "Oh, you've got the same feeder reference used by multiple things. You need to fix it." That would work. Okay, so we're just going to leave the feeder reference to be blank for now, because I don't have a way of setting it unless I specify each manufacturer part number, and I don't want to do that. So yeah, whatever. We're going to ignore the warnings. So now let's run the help again. So the next thing we want to do is set the placement ordering. Okay. And we're going to say phase is top, and the orderings is going to be, well, I only really have one option here, don't I? Currently. We know we're going to add more of these, it's fine. It's just going to be that. Because all the feeder references are going to be the same anyway, right? So it's not going to make any difference. So we're going to set the ordering. There we go. And we're going to do it for the bottom. Another thing springs to mind here. When it's refreshing the project, it's spitting out everything again. It's saying updating the placement, but the old and the new values are the same. So we're going to say to do only show updated placement if the updated placement if the new and old values are not the same. We're going to do that, and that should make it a little bit less noisy, because every time you run it, it does the same thing, right? Okay, so we're going to generate the artifacts again. And we've got some issues. A part has not been assigned to a feeder. Warning, it's fine. Is it repeating the same issue multiple times? I think it might be. Yeah, it is. Okay, so the issues need to be deduplicated. Issues need to be deduplicated. This is because we iterate over the placements and look for an issue, but we don't check to see whether the issue already exists. Check to see if the same issue already exists when creating a new one. Okay. Yeah. Because it goes over the placement, then it finds the part, and then it looks into the loadout, and then it sees there's no feeder assigned to it, and then it creates an issue, and then it looks at the next placement, and if that uses the same part, it'll create the same message again. That's what's happening here. So we need to fix that. That's fairly trivial. You just create a hash set or something, right, of issues instead of a vector, or search for it. Okay. So we've created a project, we've created the placements, we've created the loadouts file, and now we can pretend to put parts on a circuit board and do the next thing. But something's worrying me before I do that, which is this unused thing that we wrote, which was this assign process to parts. Let's have a look at the list of parts, because maybe we don't need this after all. So the project is this, and we've got the part states, and all these part states have got nothing in here, right? What do we use the processes for? I don't remember. Oh, we got a failing test. Wait, did I fix it? No, I fixed it. Everything was fine. Okay, let's look for that. Placement. So we've got this placement state. No, not that. Part. We've got applicable processes. What uses this? Nothing. Like, we add it, but nothing uses it. Weren't we supposed to be using this for something? Like when you're assigning a part to a phase, if that phase was using a process that wasn't wasn't the same as the processes that you can do with the part, then it shouldn't allow it. A bit like when it picks the PCB side, right? Yeah. We're let's see. Maybe something does use it. Hold on. But this is test code. This is test code. This is test code. This is where it adds it. That's where it adds it. Yeah. We don't do anything with this. And that's interesting as well, because I feel it sort of needs to be there, but at one point it was on here. Like, choose process for each part. And then we realised there was something wrong with this workflow, right? And it got removed. Create a phase for each process, right? Because you create a phase and you specify the process at the same time as you create the phase. So when you're assigning placements to a phase, you know what processes are going to be used by it because you just assigned it to a phase. Might need to review that. Might need to review that a little bit. Review requirement and code for applicable processes in part state. Yeah, because we wrote that before we realised there was a problem, because it was supposed to be processes instead of process. And like a while back ago we had choose process for each part, where it should have been choose processes for each part. And then it sort of didn't make sense, what we'd initially written. So I think we need to review that a little bit more still. Okay, so we're going to ignore it for now. Everything apparently works without doing it, so fine. yeah, we'll come back and look at that. So the next thing we've got to do is record placements operation. So we're going to say we've placed some things. Okay, so yeah. So what we're going to do is say that we placed something that was listed in the top placements. We're going to say that we placed this. Okay. Well, I think we might have a bit of a problem here. I think perhaps when we did some of this yesterday, we did something that wasn't quite right. Because we've got a list of ref deses, but that's not right. Because our placements list, placements file, has got object paths, not ref deses, right? Because for a given phase, you could be placing the same ref des multiple times for each PCB unit that you're supposed to be placing. Like if you've got a panel of say 6 and you've placed only ref des like R1 on unit 1 of panel 1, that's what you need to say. And then you need to say I've placed R1 on unit 2 of panel 1, right? So yeah, we might have screwed that up. I think we screwed that up big time. Oh well. I mean, this is we're dogfooding, right? So this is what we expect to find. Some quirks. QA fail. You know, that kind of thing. Okay. Let's look at what we said, because I don't think it's right. Lana. Refdes string. Yeah, this should be a object path list. Because what we're going to, if we say I placed R1, it would say I've placed R1 for all of the placements that match R1, which would include all of the objects. So that's no good. Yeah. Placement state placed. Yeah, we need to fix this. We need to have object paths. Okay, so we need to fix that. Okay, so let's just go fix me. Well, let's go to do fix. What was the thing we were trying to do? Record placements operation. Now, for this particular test case where we're not dealing with a panel, what we've currently got would work. Because I can go ref des and then go A1 and then A101 as well, right? Well, yeah, it should work out the phase automatically. Should be fine. Perhaps if the phase was specified when you were recording the operations, you could validate it a little bit more, but you don't need to specify the phase, because the object path can only be in one phase. So we're just going to say we placed A1. Well, okay, let's do 2 just to make sure that works. Let's go back to the list. We've got A1 and A201. And let's go X1 just to make sure that works as well, because it shouldn't find it. Oh. This hasn't got... why doesn't that work? Oh. And then what was the operation? Yeah, possible values placed. There we go. So we placed them. We've placed parts on a circuit board. Amazing. We've got a workflow. Okay, let's generate the artifacts again now. Okay. I don't really think the artifacts actually changed. But let's look at the project. Let's look at the project. And then let's search for A1 in quotes. Right? A1 placed. Ta-da! We placed parts. So what we've established is the workflow mostly works, which is excellent. We used a real-world test, right? We've got a real-world PCB design, and we've placed components on an imaginary circuit board using the tools. And we did the part substitution, we looked at parts and all this kind of thing, and everything's fine, and we've placed stuff. And it works, but it's currently not very easy to get a list of parts to say, you know, what hasn't been placed and what has been placed. I'm wondering if you regenerate the if you regenerate the artifacts, should the placed flag be in it? It shouldn't be. I'm thinking that if you looked at the placements list again, you can see where you got to, but that's not the remit of this tool. And if you did that, if you put the placed flag in the placements list, then it wouldn't make sense to reuse the same file again, right? Because then it would have this placed thing, you know, the next time you want to do the same process. It would be no good. But, ooh, that's an interesting point, yeah. So what if you wanted to run this process again? So I've built one, right? I put all the parts on the circuit board, and then tomorrow it's the next day, and I want to build another one, right? The problem is, all of our project stuff is absolutely fine, but the project state has got this placed flag, which has been set. So I think what we need is like a reset operations. And potentially a log. I started writing something here. Fix. Oh dear. Oh yes. Yeah. Fix. The last phase. It was the last thing that we did, wasn't it? What was it? Record placement operation. Yeah. So, oops, that it takes object paths, not ref deses. Takes list of object paths, not list of ref des. Yeah. Right. This one's the most important thing to do, really, because yeah, that's quite broken right now. Never mind. Yeah, that's definitely. Well, this is improved, really. This isn't really a fix. The other thing is issues need to be duplicated. Fix issue duplication. So there's two main issues, and there's some improvements that we can make. Oh, that looks like a lot of work, doesn't it? Yeah, and then we said to do two more things. One was like a log, and the other was like reset, add command to reset placement operations. I mean, do we need to mark a phase as being completed as well? Like, have all the operations been applied to it? That should probably be able to be determined automatically if all the placed was set true. And if they weren't, there should be an error. And then you should be able to look at the status of it. So perhaps there should be log placements as they are made. Sure. Yeah. And why? For later review, history, etc. What did I just say a moment ago? I've forgotten. Phase. Yes, that was it. To do show phase status in report, e.g. place. Let's have a look. Placements total and placed placements total. So let's say 10 of 15 components placed. You know, that kind of thing. Okay, that's a pretty good list. That's a pretty good list. All right. Yeah, well, I've got some work to do, haven't I? Not today, though. Well, okay, I might do some of it later. But now, it's lunchtime. We've been going 3 hours today. 3 hours. Wow. Yeah. pretty good. Pretty good. Got a lot done though. Right. This is great. Okay, so yeah, so I guess I'm gonna, work on fixing some of these things, and then looking into this. I think is probably sort of high on my list as well. Let me order these a little bit. Yeah. Yeah. I might do a couple of the little ones first and then look at the big ones later, or I might just do the big ones first. I don't know. But we'll see. All right. So I'm going to leave it there, people. So we've asserted that the process itself works mostly for a single unit of a PCB. It works. The process works. This is good. The same process can be used. The same workflow can be used for doing pick and place and manual placements and other operations that we deem necessary in the future, such as solder paste application, for instance, and optical image inspection and all this kind of thing, right? We've got the way of capturing the details on our phases and operations, and that's kind of the key bit to this, and we've got an overview of the status of the project at any time. Obviously, things are in JSON files and CSV files and so on, but as time progresses, we can build nice user interfaces for this and make it easier for humans to use. But as a thing that exists, it's getting there. I'm happy with it. Cool. Okay, so just remember, folks, it's only software. How hard can it be? We'll find out on the next one. See ya!